Hello there. In this video we're going to start calculating centers of mass of non-uniform objects by considering this very nice and easy example here. So I have some rod of length L, and it has some linear mass density equal to gamma x cubed, where gamma is some constant and x is measured from the left end of the rod, which I've called x equals 0. Okay, and we want to find this rod's center of mass. Of course, we can think of this rod as being made up of a bunch of little infinitesimal mass elements, dm, right? And each of these infinitesimal mass elements, they're going to be located, draw this straighter, at some, position vector, which I'll call r, right? And very generally, we can define the center of mass r, capital R, is defined as the integral over my rod of, r dm divided by the total mass of that rod m. Of course, this position vector r here is going to be very, very simple, right? Because we just have a 1D problem, right? This little infinitesimal mass dm is just going to be at some location x, right? In the x hat direction, right? So this equation here is going to simplify down very quickly to just integral over my rod of x dm over my total mass, and of course this is in the x hat direction. Right, now with these types of problems, when we're given a non-uniform mass density, then this mass m here, right, we don't know what this mass capital M here is. We have to solve for that too, right? So of course, we can do that very easily, right? The total mass, that's just the same as integrating, right? Adding together all of my little infinitesimal mass elements dm over this rod, right? Summing those all together is going to give me the total mass of my rod, m. Right, we can't really use these integrals yet because we have this non-spatial integrand in these integrals. So let's go ahead and fix that real quick. So we have mass density, right? A linear mass density, lambda of x, is defined very generally as the infinitesimal mass element per each infinitesimal length element of your object. So in other words, dm is going to be equal to lambda of x dx, and we're given lambda here. So dm is equal to gamma x cubed dx. And now we just have to substitute this guy in for our dm's. So let's go ahead and do just that. So I have integral of gamma x to the fourth dx over integral gamma x cubed dx. And where are each of these integrals going to range from? Well, our rod has a length L, right? So it's going to range from x equals 0. And then they're going to range all the way to the end of the rod, L. Beautiful. And of course, this is all in the x hat direction. These gammas are going to cancel out with each other, and now we just compute these integrals. We're going to get, this is nice and easy, 1/5 L to the 5th over 1/4 L to the 4th, right, x hat direction, and we just cancel, and we're left with, right, 4/5 L in the x hat direction. And there we go. That was a nice and simple example walked through of a non-linear mass density center of mass. If you enjoyed this video, found it helpful, let me know in the comments and consider subscribing to the channel. I love to hear about people getting on board. But other than that, thank you so much for watching.